Next up on our discussion on fluid motion, let's take a look at a couple of examples. Let's have examples part 1. Okay, so we have sample problem number 1. A student studying scuba diving is practicing in a pool. He takes enough air from his tank to fill his lungs before abandoning the tank at depth L. He does not exhale as he ascends, and upon reaching the water surface, the difference between the pressure in his lungs and the pressure at the surface is 6 kilopascals. Determine the depth L. So, the scuba diver, the student, does not exhale as he ascends, which means he maintains the pressure in his lungs when he breathes in air from the tank at depth L, which means the pressure in his lungs is equal to the pressure at depth L. At the surface, the difference in the pressure between his lungs and the pressure at the surface is 6 kilopascals or 6,000 pascals. The pool is filled with water, and we know the volume density of water to be 998 kilogram per cubic meter. And we are looking for depth L. Let H be equal to L. The pressure at depth L, that's basically the pressure inside the student's lungs. P is equal to P naught plus rho G H. H is equal to L, therefore, let's replace H with L. So we have P naught plus rho G L. Transferring P naught to the other side, P minus P naught. P naught is the pressure at the surface of the fluid. In this case, the surface of the water in the pool. P minus P naught is equal to delta P, 6,000 pascals. Delta P is equal to rho G L. We are looking for L, so isolate L. L is equal to delta P over rho G. We know delta P. We know the volume density of water. So we know rho. And we know G. G is just acceleration due to gravity magnitude. So 9.8 meters per second squared. So plot in the values and we are able to calculate the depth L. L is equal to 0.613 meters. Next, we have sample problem number 2. A wooden cube with side length of 0.25 meters is placed in water. It floats on the surface, on the water surface, with half of it submerged. Determine the mass of the wooden cube. So, wooden cube, side length of 0.25 meters. So, let that be L. L is equal to 0.25 meters. Water, we know the volume density of water to be 998 kilogram per cubic meter. With the wooden cube floating on the water surface with half of it submerged, determine the mass of the wooden cube. The cube has side length L. The volume of the cube is just L cube. Half of the cube is submerged, meaning half of the volume of the cube is displacing the water. So the volume of the displaced water is just half the volume of the cube. V cube divided by 2, V cube is L cube. So L cube divided by 2. Knowing L, we are able to calculate the volume of the displaced water, 7.8125 times 10 to the negative 3 cubic meters. Knowing the density of water, knowing the volume of the displaced water, we are able to determine the mass of the displaced water. Raw water is equal to mass of the displaced water divided by volume of the displaced water. Volume density is mass divided by volume. Transferring V water to the other side, we have the equation for the mass of the displaced water. M water is equal to raw water times V water. We know raw water. We have calculated V water. We are able to calculate the mass of the displaced water. 7.796875 kilograms. The wooden cube, rather, is just floating on the water surface. It is suspended in place. Static case, F net is equal to 0. We have two forces acting on the object, the weight of the cube, and buoyant force coming from the water. You could also use the equation weight apparent is equal to weight of the object plus buoyant force. Since the object is just suspended in place, the apparent weight is 0. So 0 is equal to weight of the cube plus buoyant force. You get the same equation. This is vector equation, so we use component method. But since weight is vertical, the same goes for buoyant force. All our vectors are vertical. No x component. We go directly to the y component. Y component of 0 is 0. Weight is negative direction. And opposite the weight, buoyant force is positive direction. Weight of the cube magnitude is just mass of the cube times g. We know we are looking for mass of the cube rather. Buoyant force magnitude is just the weight magnitude of the displaced fluid, in this case, weight magnitude of the displaced water. So, FBF magnitude is just M water G equal to 0. So, the equation negative M cube G plus M water G is equal to 0. We can cancel out G, meaning M cube is just equal to mass of the displaced water. So, mass of the cube is 7.797 kilograms. In this example, the wooden cube, the object is suspended in place. It's simply floating in the water. The weight apparent is 0. But variations of this is that the cube, the object, will either sink or it will move up. It will move to the water surface. In which case, F net will not be equal to 0. F net will be equal to MA. So please take note of that. And that's it for now. In the next video, we'll continue our discussion on fluid motion. So thank you for watching.